You ever have that moment when you think you know something, and then, bam, it turns out to be way different?
Happens all the time, even in paleontology.
Right. Like, take Anodontosaurus. It's this really cool armored dinosaur, late Cretaceous. But for ages, well, it was a bit of a scientific puzzle.
All because the first discovery was kind of misleading.
Exactly. So today, we're doing a deep dive into the story behind Anodontosaurus.
Yeah, we're looking at the science, how it was found, how scientists figured out what it actually was.
And the fossils we're talking about, they're mostly from Canada, right? Southern Alberta.
That's right. From rocks dating back, roughly 75.6 million years ago, down to about 67 million years ago. Late Cretaceous, definitely.
So our mission, really, is to trace how our picture of this dinosaur changed, from discovery, classification, what it looked like.
And how it relates to other dinosaurs. It's a fascinating journey.
Okay, let's start at the start. 1916, Charles Mortram Sternberg.
Yep. He found the first bits near Morin, Alberta, from the Horseshoe Canyon Formation, the upper part of the lower section. Dates to around 71 to 70.2 million years ago.
And the name, Anodontosaurus. Toothless lizard. That sounds wrong for a herbivore.
Well, it was wrong. But you see, the first skull they found, the holotype specimen, CMN 8530, it was really badly crushed.
Ah, okay. So the damage made it look toothless.
Exactly. Compression sort of shifted things around, and some broken bits were actually mistaken for trituration plates, like grinding pads.
Wow. So the fossil's condition really sent things off track initially, even though that first find, CMN 8530, had a skull, neck armor, body armor, lots of stuff.
It did, yeah. Badly crushed, but it was a start. And then later, much later, another important piece came along.
That would be the second species.
Right. Anodontosaurus inceptus. Its holotype skull, TMP 1997.132.1, actually came from the older dinosaur part formation.
So that pushes its timeline back even further.
Tells us this type of Ankylosaur was around earlier, yeah. Around 75.6 million years ago.
Okay, so putting aside the crushed skull and naming issues, what did Anodontosaurus look like when it was stomping around?
Well, think classic Ankylosaur, but maybe medium-sized for the family. Research suggests around maybe 4 to 5 meters long.
So 13 to 16 feet, roughly?
Yeah, about that. And maybe weighing around 2 metric tons, so 2.2 short tons. A solid, 4-legged, ground-hugging plant eater.
And covered in that amazing armor, I assume.
Oh, definitely. Extensive armor plates on its back, and that wide, pointy tail club. The iconic Ankylosaur weapon.
Can't forget the tail club.
No way. And the skull had some neat details, too, like these small bony plates behind the eyes called postocular capitegulae, polygonal shape.
And there's another tail club specimen mentioned, AMNH 5245.
Right, that's a referred specimen, not the original holotype, but believed to be the same species. It helps show us a bit more about that tail club variation.
Okay, now the classification part sounds like it wasn't straightforward. A bit messy.
Oh, definitely messy. It highlights how science works, Ideas change. Back in 1971, Walter Coombs had this influential idea.
What is that?
He basically proposed that during the Campanian age in North America, there was really only one kind of ankylosaurid, Euplocephalus tutus.
Wait, only one? So what happened to Anodontosaurus?
It got lumped in. Anodontosaurus lambi, Diplosaurosaurus. Coombs suggested they were all just variations of Euplocephalus. So our original find, CMN 8530, was suddenly labeled Euplocephalus.
Wow. So this distinct dinosaur just vanished into another species, taxonomically speaking.
That's pretty wild, yeah.
So what brought it back? What made scientists say, hang on, maybe these are different after all?
Well, a few things started chipping away at that idea. First, Diplosaurosaurus was restudied and found to be a valid separate genus in 2009. That opened the door.
Okay, so one piece was pulled out of the Euplocephalus lump.
Right. Then Victoria Arbour presented research in 2010. She pointed out some really distinct features in the skull ornamentation, the neck armor, even the knobs on the tail club of the Anodontosaurus material.
Features that didn't match Euplocephalus.
Exactly. Subtle differences, but consistent. Things that suggested it really was its own thing.
So the tide started to turn.
And after that, researchers started going back to museum collections. Lots of fossils from the Horseshoe Canyon Formation that were labeled Euplocephalus. They got re-identified as Anodontosaurus.
Giving it back its identity, piece by piece.
Precisely. And then more studies came out solidifying it. Penkalski and Blows in 2013 also supported Scolosaurus being separate.
Okay.
Penkalski the same year also named Ukatokia, another Ankylosaur. And his analysis placed the Anodontosaurus holotype kind of uncertainly in what we call a polydemy alongside Euoplocephalus. Still a bit fuzzy.
Right.
But then Arbour and Curry formally published the revalidation of Anodontosaurus.
Mm.
And initially they put that dinosaur park specimen, TMP 1997.132.1, into Anodontosaurus as well.
Which extended its time range significantly back then.
Yes, but then Penkulski in 2018 looked closer at that older specimen.
And decided it was different enough.
Different enough to be its own species. That's when it became the holotype for Anodontosaurus insectus. So you see, it's a process. Discovery, lumping, splitting, refining.
It really is like detective work over decades. Speaking of different stages, there's also mention of a juvenile specimen.
Ah, yes, AMNH 5266. This one was interesting because Coombs, back when he was lumping things, identified it as a juvenile Euoplocephalus in 1986.
But it was found way earlier.
Much earlier. Barnum Brown found it in 1912, also in the Horseshoe Canyon Formation. It's not a complete skeleton, but it has vertebrae, ribs, a whole hind limb, bits of the feet.
And how did Coombs know it was a juvenile? What were the clues in the bones?
Several things pointed to it being young. Like the main part of the vertebrae wasn't fused to the arches above them. Sacral ribs weren't fused properly.
Things that would be fused solid in an adult.
Correct. Also, the surfaces of the long bones were smoother, lacking the rough spots where big muscles attach in adults. The top of the thigh bone, the femoral head, was less spherical. And the lower leg bones, the tibia and fibula, weren't fused to the ankle bones. Even a hand bone had a shape suggesting immaturity. All classic signs of a younger animal still growing.
So even if its species identification shifted later, it gives us a window into how these big armored dinosaurs grew up.
Absolutely. Growth patterns are super valuable information.
Okay, so finally, where does Anodontosaurus sit in the big dinosaur family tree, phylogenetically speaking?
The analysis by Arbour and Curry in 2015 places it firmly within the Ankylosaurinae subfamily. More specifically, within a group called the Ankylosaurinae.
So related to the really famous ones.
Yeah, it's shown to be related to giants like Ankylosaurus itself and also close to Euoplocephalus, ironically, the genus it was once lumped into. That cladogram helps visualize those relationships.
So quite the journey. From a toothless misnomer based on a crushed fossil to being absorbed into another genus, then reemerging as its own distinct dinosaur with now 2 recognized species.
It really underscores how paleontology works, doesn't it? Our understanding is constantly being refined.
Yeah.
New finds, new analyses, re-examining old stuff.
It's never really finished.
Not at all. The story of Anodontosaurus is a perfect case study in that scientific process. Always questioning, always learning.
It really makes you wonder, what other facts about the ancient world that seem settled right now might get completely overturned or tweaked by the next big discovery, or just a fresh look at the evidence we already have.
Exactly. It keeps things exciting. Our picture of the past is always evolving.